Thus this ratio, this one, will be coming out to be the same as in the T model. In T model we had small re divided by small re plus capital Re, right? And that ratio and this ratio would be the same, right, as per our finding regarding this thing. Okay, so this is all about common emitter amplifier with emitter resistance analyzing with pi model instead of the recommended T model, right? So now what you have to do, you have to include this pi model based analysis of common emitter amplifier with emitter resistance in your homework 4, right? So you have to do this alongside with the homework 4. In homework 4 you already did the analyzation using T model, just include pi model besides that one, right? You have been doing this, you had been doing this. So now you have to find also with this pi model, you have to find AV and GV yourself as did with T model. A little discussion about the common amplifier circuit discussed in the book, right? So please don't be confused when you see this circuit in your book. In your book, the discrete amplifiers or BJT amplifiers, you would be having common emitter amplifier with RE and others. So let's consider the book circuit of common emitter amplifier. So here this circuit is basically drawn for AC analysis because the book author understood that you already have analyzed the DC properties and Q point and load line. So he is analyzing the AC properties, right? Still, he showed you the VCC and VEE, but here he showed that it would be zero because it will be shorted to ground. This one also, right? So it is actually the AC equivalent circuit, right? And AC equivalent circuit, capacitor will be short circuited. So he showed you without opening it. He showed the VCC so that you could be having a vision of DC biasing, but for AC it would be appearing as zero. This one also, and you have, if you have RE, but then it will be bypassed. It would be bypassed, or you don't have an RE. So if you don't have an RE, that's why we write common emitter amplifier only, right? So all other things are same. So if we replace this with its model, equivalent model, because the emitter is appeared to be ground because of this coupling capacitor, we use pi model, and at the base side you have RB to grounded, capacitor shorted, R signal, V signal, right? At the collector you would be having RC to ground and RL to ground, RC to ground and RL to ground. You can use early effect mode part also in your model because the emitter is grounded. So these three resistances are coming in parallel. When you want to write the V naught would be equal to what? GM VBE or V pi multiply by minus sign minus GM V pi R naught parallel to RC, right, without RL. With RL, minus GM V pi RC parallel to R naught parallel to RL. Okay, so when you put the V pi instead of V in, luckily V in would be the same as V pi. So this is your GB naught, AV naught relation. When you put it down, then minus GM RC parallel to R naught will be your AV naught relation. Your AV relation is including RL. So just bring this V pi down. Minus GM RC parallel to RL parallel to R naught. It would be your AV relation, right? About GV, you have to put a relation of V pi so that you can bring V signal here. So V pi, which is V in, is same in pi model with emitter grounded. So V in or V pi will be equal to Rn divided by Rn plus R signal into V signal. You can put it here. It means your GV, I am giving you the relation of GV. GV will be equal to minus GM Rn divided by Rn plus R signal into RC parallel to RL parallel to R naught plus Z. Okay, and in your book you have common emitter amplifier with emitter resistance. The circuit is shown like this, right? He showed you an emitter resistance, a discrete emitter resistance. It is a capital letter. Forget about this one. He actually used this small subscript instead of capital subscript to show, to actually present you that he is also showing, already he is although showing the DC source but shortening to ground, because he is actually in the phase of doing AC analysis. Okay, so in AC part, this resistance R capital R capital E will still be available. So that's why he used capital R small e. So please don't get confused with this one, right? And he also showed in general that maybe you have many resistances at the emitter, all of them are bypassed, but if only one is present here, you still have a common emitter amplifier with emitter resistance, right? Otherwise, you can put this signal to ground. It means you have only one resistance, nothing is bypassed, right? So it means whatever is, if other resistances, but still one resistance is present, so you are in this amplifier case. So again, here you can still perform the AC analysis. Here he showed you this RIB, Rn, this will be your stage excluding RL and this source part, or you can make a T model. T model, why? Because we have a discrete RE here. So replace this with its T model. Forget about R naught, means neglect early effect, this one, and now put the resistances, other components. So emitter have a resistance to grounded, this AC, this capacitor will be short circuited, so this will be bypassed, this one, right? RB at the base, R signal also at the base. At the collector you have RC to ground and RL to ground, RC to ground and RL. Okay, here he write AC current IC as alpha IE. It means you have to find IE here, then you can multiply with alpha, you get IC. We already know that these are the same thing. If you find VBE here or V pi here, VBE, then GM will be the current here. So these are all equivalent things, right? So he used alpha IE. So there is the current through this resistance going here. If you neglect this one, you are actually writing the value of V out excluding RL. It means you are considering to find AV or AV naught, right? So R naught is RC, but with RL you would be having this relation minus alpha IE. So when you put IE here, you can put it here to find V in down, then you can find AV and AV naught. Same way as we did. Or it is better to find V pi or VBE and use the same relation as I did instead of this one. Instead of this one, what would be the output relation? V out is equal to, with RL, I am telling you with RL. V out is equal to minus GM VBE RC parallel to RL, right? So you have to now put VI instead of VBE to get AV, or V signal instead of VBE to get relation of GV naught or GV. Okay, and what would be the relation of VBE with V in or VBE with V signal? I already told you when we considered the T model, the circuit with common emitter circuit of common emitter amplifier with emitter resistance. Please do these things. And again, don't be confused with these symbols. It is saying that it would be having some resistances here, having DC current. Obviously, if we have a resistor here, it is having a DC current, but no AC current passing here because of this coupling capacitor. So it is just showing you that. Thank you very much.